All right. Okay. So, for today's video, just a little video. I don't know if this will be little because I have three examples here, and this is meant to be a supplement for interpolation. Right? Interpolation, as you may already know, is basically the process of inserting or basically inferring a kind of value or a piece of data or a data point from, say, for example, a given data set. And in this case, right, in the case of thermodynamics or basically any other related kind of topic, we usually use linear interpolation. It's easy to do, right? And it doesn't take up a lot of time, hopefully, right? And now, my goal for this video is for you guys to use your brains and your calculators in a more organized fashion. AKA, I will now be teaching you calculator techniques for easier interpolation. So, let's say for example we have here water, right? Water. So let's skip to our saturation tables first. At 5 bar and 295 degrees Celsius, what will be the specific volume of this sample of water? So first, before anything, right, we should first understand what state this is in, right? If you're given pressure and temperature, most likely it will be a superheated vapor, but we just want to see, right? We just want to see for certain. And so that means either we go to our pressure table or our temperature table. Let's just go here, right? We have our pressure of 5 bar, so we skip the 5 bar. That means its corresponding saturation temperature is 151.9 degrees Celsius. The corresponding for this should be 151.9. But it's higher, which means that this thing is indeed a superheated vapor. Good job to us, right? Good job to us. Sorry, I just wanted to see. So this is a superheated vapor. So now we have the license to go to our table A4, right? Superheated water vapor tables. And so we go to our pressure table for 5 bar, and there is a 5 bar, right? However, this 5 bar does not have, right? If we're just going to copy paste our values here, oh my goodness, as we can see in here, there is no value for, right, 295 degrees. However, there is a value that is lower than 295, which is 280, and a value that is higher, 320. And so now, our goal is to basically find the value that is sandwiched between 280 and 320, right? The visual representation for this is as follows, right? We're going to just draw here a line, right? We're just going to draw here a line. Say, for example, this is your V, this is your T, right? At a temperature of 280 degrees, let's just have a little break in here. A little break in here as well. Right? At a temperature of 280 degrees, and say, for example, this is 320, right? At a temperature of 280 degrees, we have a specific volume of 0.5. Let's just say, I don't know, this is 0.5. Let's move this a little bit. Okay. 0.5 and let's say 0.6. I don't know, something like that, right? Let's say we have here 0.5034. So somewhere here, right? Somewhere here. And then your 320, right? At 320 degrees Celsius, your specific volume is at 0.54. So somewhere here. Now, what we want is a value for 295 degrees Celsius. So somewhere in here. And so if we create a line between these two values, we will create, or rather we will see in here, an intersection point, right? Let's have it in red. Yeah. So we will see an intersection point in here, and what we want from that is basically our value for letter V, right? We know for certain that that is not there, right? Or most likely it is not there. However, this is a pretty good estimation for this value of V. And so what we usually have done, right, is mid minus small over big minus small, right? If you remember, mid minus small over big minus small, over big minus small is equal to your corresponding value of mid minus small over big minus small. As we have stated before, right? As we have stated before, this is the corresponding value. This is not pertaining to the numerical value. Corresponding value to here, corresponding value to here, corresponding value to here, and to here. And so in this case, right? In here we have, right? In here we have our small value, right? This is at 280 and then 0.5034. And in this case, this one is now at 320, 0.5416. And so what we can do, right, is just substitute our values in here. V minus, right, whatever that is, 0.5034 is equal, all over, right, 0.5416 minus 0.5034. Or in other words, right, that is equal also to the proportion of, what are we supposed to get? 295, right? 295 minus 280 all over 320 minus 280. The thing is, you can shift solve for this using your calculator, right? You don't have to go all the way as to just like, as to calculating this on your own, right? And for those who still do not know how to do this on your calculator, what you can do is just type this into your calculator, right? But because we do not have V, right, the easiest one, the easiest substitution in here will be the letter X. You can get your value of X by getting the alpha, right? Alpha, usually that is letter, or that has the color red or the color blue. In this case, for the canon, it is blue. And the X is usually in here, in the closed parenthesis, right? It's here. That is the way to get your X. And so you can put all of that into your calculator, right? You can get X minus 0.5034 all over, right? All over your value of 0.5416 minus 0.5034. And do not press equals, do not press equals. As you will see on the upper left, there is another equal sign that is colored blue or red, right? In that case, what you're gonna have to do is get again alpha, right? Get alpha again. Honestly, we can just get everything in here, right? And then there is, in this case, the word calc. This is for my Canon, right? This is for my Canon F789 SGA. That is how you're going to get your equals sign, and you can get the rest of this in your calculator. Okay, so 320 minus 280. Okay, and from then, what you're going to do, this is why it's called shift solve, right, is look at your shift button, right? Your shift button is either colored yellow or orange, right? Shift, and then what you're going to see in here is you're gonna look for the word solve, right? Usually that's under the calc button, right? That is why we call this shift solve. And then when you do shift solve for this, say for example, I will do this on my end, 5034 5416 minus 0.5034, you will get 295 280 320 280. You will get this prompt, right? Your calculator will ask you solve for X, right? Solve for X. And then, right, sometimes your calculator, if it's a class whiz or if it's a Casio, it will just ask you X, and then you have a value on your lower right side of the screen, right? You'll have a value on the lower right side of your screen. For now, you don't mind it, right? You just press equals again. But for those who require a more technical explanation, this value right here, currently I have it at 0.02. This is your current value that is stored for the letter X. Okay, that is the value that is currently stored for the letter X. The thing about this letter X is that this will serve as your calculator's initial guess. Your calculator is actually a little bit stupid. Stupid in the sense that it does not sense that this is something that it can solve for using algebra. What calculators do for them to solve for this value of x is they implement an algorithm. They cannot think, right? In the same way that, say, for example, we think, or more advanced models like Wolfram Alpha can think, right? They just implement an algorithm, right? And so if you want, right, you can have, or you can input an initial guess. Say, for example, if you want your calculation to be faster, you know that your answer should probably be somewhere in the 0.5 region, right? So if you want, you can input in here 0.5, right? What I will do is I will input 0.5, and then, right, I will press equals, right? This is just for the calculator to have an easier time. And an easier time means a faster time. So, if you have a little guess as to what the answer should be, right, you should probably put it in. But in these cases, this is what we call a linear equation, right? You only have here an x, and this is pretty easily handled by the calculator. So what the calculator will give you is this value of x, which on my end is given as 0.517725, and this thing is L minus R is equal to, and then they have there a 0. X in here really is just the value of x that you have gotten. And now, the next time that you try and get the value of the next time you try and get the value of x, say for example, if you do this and you just press equals, you will see that it is now stored as the value of x, which is very useful. But now let me explain what this L minus R means. That means left minus right. That is how your calculator actually tries to iterate, right? It implements an algorithm that gets better and better, and it will get better and better, more accurate values of x, and it will stop once the left minus the right side is equal to 0. Or in other terms, if you put this to the other side, it will stop when your left is equal to the right, which makes sense, right? And so in more complicated calculations, say for example in the future when you're in your 4th year, you will find that the calculator stops when it's at, I don't know, 5 times 10 raised to -6. The calculator is like, you know what, this is close enough, right? This is small enough, as you can see, right? It's a very small number. It's not 0, but the calculator is like, it's tired. It doesn't want to do it anymore, so it will stop at an approximate solution. In this case, because this is a linear equation, this is very easy. So that means it can get an exact answer. And so that means that your V in this case, right, your V in this case is just equal to 0.517725 meter cube per kilogram. And so now I will be teaching the other way, right, the other way. And so I will be teaching this for both, right, for both the Canon F789 SGA, right? So the Canon F789 SGA, the transparent version, or the Casio FX570 ES. And I'm teaching this for these two versions because these are the current front runners for the board exam. Both of these, at the time of recording, which is currently October 21, 2025, at time of recording, these are still both approved by the PRC in the use for board exams, right? However, maybe someone in the future is gonna cheat with either of these, and then both of them are going to get banned. Hopefully not, right? I'll be teaching this for both, right? And for both, right, what you should do is you should press the mode button, right? The mode button. And as you can see, for the Canon F789 SGA and for the Casio 570 ES, right? The number 3 should give you stat, right? It should give you stat. Let me actually get my Casio. Hold on. Okay. So for the Casio, I have both of them now. Oops. Mode, right? For both of them, you will see stat, right? So if you press number 3, you will now be presented with other options. So for the Canon F789 SGA, right, or actually for the both of them, honestly, you can just look at number 2. Number 2 for the Canon F789 SGA, let me put this with the letter blue. Right? Sorry, the color blue. And for the Casio, I'll put this with the color red, right? For the Canon, it looks like lin, right? Lin stands for linear. And for the Casio, it looks like A plus B X, right? A plus B X, which both of them, look at that, right? Both of them are describing linear, right? Linear, I don't know, statistics, right? And so once you are in this mode, what you will see for both the Canon F789 and the Casio F570, you will see this table, right? You will see this table right here. You'll have 1, 2, 3, and you will have X, then you will have Y, right? Y, and then this other thing. And now, what you're going to do currently, for both, right? For both, what do you call this? For both calculators, right? You have this cell currently highlighted. So what you will do is now you will try and turn this into a table problem. What do we mean a table problem? Right? I've probably done this in class already, but, right? The temperature and the volume, right, can be interchanged, right? Say, for example, you do it like this, right? You do it like this. For the temperature, you have a value of 280 and 320. What you want is basically the value for 295. And for V, you have here, what was that? 5034. And you have here 0.5416. What you will now do is, for the first one, you will type in this value, 280. Right? So once you type in 280, you will press equals. It will now go and fill out this thing with 0, and then it will have this one highlighted next. So instead of getting the 295, right, because that's the one you want, we skip to the value that we know, which is 320. So we put in 320, we press equals, and now do not fill in the third thing. What this basically is doing is that it's trying to log different values for, right, for the points that you're going to use. In this case, honestly, you can get more and more values, right? So, kumbaga, right, in other words, right, you can actually create in here linear regressions, right? The more points that you get, the more that the calculator can try and get the best fit line, right? The best fit line. But in this case, we are using this mode of the calculator for a simple linear interpolation, which means just 2 points which create a perfect line, right? So in this case, you just navigate with your direction buttons, right? And you go into here, right? And you edit this value of 0. You edit this to 0.5034, right? And then 0.5034, and then you press equals, and then you edit this value now, which you will have to punch in 0.5416. Press equals. Now, once you've punched in these values, what you can now do is press for your Canon F789 SGA. For your Canon, press in CA, and for your Casio, press in AC, right? Either of those. So you press it, and now what you will see is this screen right here. Is this screen? Oops. This screen wherein it says 0 down here, right? And there's a blinking cursor in here. And so now what you will do is you will ask it the question, what value of V, or in this case, what value of Y, because that is the second column, what value of Y corresponds to an X value of 295? Okay? So in this case, what you want to do is you want to type in 295. 295. And so now, what you will access is Y hat. Where do you access Y hat? Well, for the Casio, or sorry, for the Canon first, we will look at the apps, right? The apps button. And then in the apps button, once you get there, you will look at number 8, which is regression, right? And then you look at number 5, right? Number 5 is y hat. And if you look at number 4, right? Number 4, that is x hat. So you might want to remember that as well. Note your number 4. Oops. Your number 4 in here is x hat. Now, we will press y hat. And so that is how you get it in your canon. For your casio naman, right? For your casio, you are supposed to look at the numpad, right? If you see in the numpad, there is the word stat on the number 1, but it's yellow. So what you should do is press shift, right? Press shift so you can access that yellow bit, right? And then go to number 1, that is for your stat, right? So shift 1, and then as you can see in here, you will also see the number 5 regression. And then if you press number 5, and then if you press number 5 again, that is for your y hat. And again, note that number 4 is for x hat. Huh? Okay. So if you do this and you press equals, you will not be presented with the same answer, which is going to be 0.5177725. So that is how you get it without going through the whole hassle of doing this, right? Of course, there are advantages and disadvantages in here, right? Such as you can very clearly see that all of the values for V are in one side and all of the values of V are on the other side. What does that mean? You're less likely to get this wrong. However, the disadvantage here is that you are more likely to get it wrong if you forget the corresponding, right? If you get the corresponding rule wrong, okay? At the very least, this one has the advantage of it being, how should I say this? Intuitive. Intuitive in the sense that you can clearly see what one side is and what the other side is. The other disadvantage of this thing is that it takes time. It takes time to set up the whole thing, and then boom, 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 you shift solve, and then you get the answer here. Honestly, if you have been stuck with this, what do you call this? With this technique, you've probably gotten very fast at it, right? And by the point, before I was taking my board exam, I have been exclusively using this, because I was not very sure what this thing is supposed to be. But yeah, now I can use either without me having to slow down, I suppose. Right? Now, the very interesting advantage for this thing is that, well, everything is done for you, right? This is very mechanistic in the sense that if you like memorizing, just memorizing your techniques, if you want to be algorithmic in the sense that you don't have to think about the values, this may be the technique for you, right? On the other hand, though, right, it might be prone to error because you might set this up the wrong way. What do you mean you set this up the wrong way? Say, for example, you have switched the value 0.5034, 0.5416, and then 280, and then 320. In this case, if you say 295 y hat, what you might get is something like this. Ngayon lang ha. 295. You might get something like this. 308,653,4031, which is very, very wrong, right? That's a very big number that does not look like V at all. That is because you should instead use X hat, because now you're asking the calculator what value, right, of X corresponds to a Y value of 295. So you might be prone to error in that regard, but supposing that we set this up already the correct way, this is a bit more simple on the eyes, right? This is a bit more simple on the eyes. I've not done any tests that conclusively say whether one technique is faster than the others. I'm just presenting this to you as an alternative if you think that this is a lot to take in. Okay? And so now we try this out for our second example. R22. Okay, so we go to R22. R22, there you go. So the temperature table, let's go to the pressure table. There you go. With a pressure of 160 kPa, we can turn that into 1.6 bar, right? 1.6 bar, and you have a temperature of 12 degrees Celsius. In here, we are being asked what is the value of S, right? So first, the state. If we have a pressure and a temperature, then most likely we are dealing with, right? We are dealing with a superheated vapor. Let's just try and see if that is correct. And surprise, surprise, there is no value for 1.6 bar, right? Even if there's no value for 1.6 bar, we should still be able to look at it on the side of the temperature table. 12 degrees Celsius. 12 degrees Celsius has a saturation pressure of 7.2307 bar. And this is bar. This is not degree. This is not kPa. No, nothing. And as you can see, right, this has a corresponding saturation pressure of 7.2307 bar, but it is lower pressure. It's not compressed, so that means it's not a compressed liquid, which means again this is a superheated vapor, which is correct. And so now, right, honestly, if you still look at the side of the pressure, right, the pressure table, you will see that it's somewhere between here. But look at the corresponding saturation temperatures. They're both really low. This thing is 12 degrees Celsius, which is higher than both of these states or both of these saturation temperatures. It is very clear from here, although we do not see a value of 1.6 bar, it's very clear that the temperature is higher, which means superheated vapor. So we now go here and surprise, surprise, there is no pressure table for 1.5 bar. Okay, so that means that we're gonna have to triple interpolate, right? Triple interpolate because also there is no value of 12 degrees Celsius. There's only a value for 10 and 15. So now we create this large table. This large table wherein, excuse me, this large table wherein you will have two different values. This is very large, because say for example, we have here pressure and then temperature, right? Pressure and then temperature. We will have, I will put in here slightly larger, right, values, 10, and then we want in here 12, right? And then we want in here 15, right? Or sorry, we're just looking for S, right? So no, sorry, it doesn't have to be very large. 10, right? 12, and then 15. 10, 12, 15. In here, we want a pressure of 1.5, 1.6 is the one we want. Oops. 1.6 and then 2 bar. Okay, so we can fill out the values 1, 2, 3, 4. Basically, all of the ones that are both white in text. So for 1.5, 10, we will have an S value of 1.0854. Honestly, we can just take screenshots of this so that we don't have to alt tab every single time. Okay. Okay. There you go. For 10 degrees Celsius, 1.5 bar, we will have an S value of 1.0854. For 15 degrees Celsius, 1.5 bar, we will have 1.0968. For 2 bar, 10 degrees Celsius, we will have 1.0555. And for 15 degrees Celsius, 2 bar, we will have 1.0671. Our goal is to get this value, which you can only get by getting either this and this value or this and this value. There are no brownie points if you fill out all 9 values of the table, okay? You just need to get it as quickly as you can. Why is that the case? Because once, say for example, you now get this value and you get this value, you can now interpolate between those values and get your common value here, which is your answer, right? And so now let us begin. And very clearly, if I'm going to write this down on paper, this is going to take a long time because I will have to write down 3 of these things, right? But if you're going to do this on a Casio or a Canon, the alternative way is for us to just, right? Is for us to just put this in 3 different modes, right? In 3 different mode 2s, right? So again, to invoke this kind of thing, you will do mode 3-2, right? I'll do this in exclusively in the mode 3-2 state now. You guys can do this manually, but you will see that this will give you the same results, honestly, right? So for the first one, I want to just get the values of this and this for me to get this value in the middle. So let's start with this one. I will label it number 1, number 2, and then number 3. Okay. Okay, let's start with this table, right? I will try and get this table. I will try and copy paste this table 3 times. Okay. Copy paste this table 3 times. Okay, 1, 2, and then I will have this number 1. Okay, copy paste. Let's put it here. Let's put it here. Oh my goodness. What did I catch? Oh, I removed some things. Okay. Copy, paste, right? Just paste the one here. Ayan. And then that's the first one. Second one is here. And the third one should be here. Okay, let's replace these now. 2 and then 3. And now what we will get is basically for this first one, we will have 10 and 15, right? We will now have 1.0854 and 1.0968. So let's try this. I'll put on my Casio mode 3-2, 10, 15, and then 1.0854, 1.0968. And then we AC, right? And then we ask the calculator, what is the corresponding Y value for 12, right? So now, once we go AC, right? Once we go AC, we are going to see in here, or we will ask the calculator, what is your 12 Y hat? It will give you a value of 1.08996. 1.08996. 1.08996. And now, for those of you who do not want to write this down because it's such a hassle, you know, you want to be as fast as possible without losing that kind of accuracy, you just want to store this into a value. Honestly, you don't have to even what do you call this? You don't have to even display it, right? You don't have to even press equals. What you can do in this case, once you punch in 12y, right? What you can do is shift store, right? So you can press shift and then, right? You will see in here the letters RCL. RCL stands for recall, and on top of it should be STO. STO meaning store. Shift store and just try and locate any value or any kind of variable that you have. So for the Casio, you have 1, 2, 3, 4, 9. You have 9 possible variables, which are A, B, C, D, E, F, and then X, Y, and M. You will find them on the black buttons on top, right? In the middle, pala rather. And for the canons, rejoice, because you will have A, B, C, D, E, F, X, Y, M, as well as, right? As well as all of the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now, if you want to store a lot of values, you use the canon, right? And say, for example, you just turn on the canon, right? You shift store a value to number 8. What it will do is that instead, right? Instead of the number 8 itself, you will see that it will store to a value that is underlined, number 8 underlined, so that you know specifically that you are trying to get the value of 8, right? Anyway. Okay. And if you want to if you want to recall the values for these numbers, right? You will see that on the canon, there is no, what do you call this? There is no value, or there is no parang clear shortcut where you will access this value. So for you to access these number values, you should just press recall and then the number. So in this case, number 8, you will get in here the 8 underline, right? And so anyway, right, what you can do is 12y hat, and then shift store, and then you can store to any value. Say for example, in here I will store it in letter A, which is in both, right? In both calculators, both of them are in the negative sign button. And so now this will be stored to A. I don't care about the value of 1.08996. I will just cap it and put it in the letter A. And so now we continue. What about number 2? We will now put in here, the values 10, then 15, and then for 2 bar, we will have 1.0555, 1.0671, and we will do the same thing. AC, 12y hat, and then let us store it to letter B instead. So mode 32, 10, 15, 1.0555, 1.0671, AC 12, shift 155, 12y hat, shift store to B, which apparently is equal to 1.06014, right? But I do not care, right? Because I want to do this as quick as possible, but hopefully you care about those values. And now for number 3, we will look at this table right here, And if you tilt your head to the right, you will see that both of these things are your x values. Both of these things are your x values, right? And both of these things are your y values, right? Or you can also tilt your head like this. But honestly, what you can just do is 1.5 and then 2 and get the corresponding values from there. In this case, your corresponding value for 1.5 is A, and your corresponding value for 2 is B, right? So mode 3, 2, right? And then 1.5 and 2, and then just access your value of A, alpha A, and then alpha B. Yeah, so surprise, they are now in there. Okay? Ano yung una nating value of A? What is our original value of A? 10, 15, 0.10854, 10964, 12. That is 1.0898. 1.089. Now, if you get in here 1.6y hat, right? 1.6y hat, you will be, right? You will be given the answer, right? You'll be given the answer, which is S is equal to 1.083868 kilojoules per kilogram Kelvin. And so, as you can see, right? The shift storing, right? The storing of your answers to your variables not only gives you peace of mind, na like I don't have to write them down anymore. It also gives you higher accuracy. Higher accuracy in the sense that you are no longer truncating values. If, for example, you truncated the value of 1.0898, you just wrote down 1.09, you are already including some error. Error in the sense that you did not write this whole thing down, right? In here, they wrote everything down for you. The calculator is writing down everything for you. And so, there you go. And last bit, number 3, right? Number 3, here is the hardest part of them all, okay? R134A, you have 1.45 MPa, which translates to, right? Which translates to 14.5 bar. So you're already shaking in your boots. Nako, that doesn't sound like it has a very nice, row for it, right? So we need to look at this first in the saturated tables. This is R134A. Okay? Now, R134A, we will look at 14.5 bar. That is the pressure table, and surprise, surprise, there is no state, or there's no row for 14.5. There's only 14 and 16. What's worse is, right, you are given a U, not a P, not a T, which most likely guarantees it to be superheated vapor. But in this case, you're given a value of U. No, this is not great, right? And so we are being asked the value of H. How are we going to do this? Well, just put in everything you know. What do you mean? This is now where we're going to implement the harder part of triple interpolation. So currently, we have here two values of P, right? Which are 14 and 16. Which are 14. Oh, sorry, abot pala siya. Let's move all of this to here. 14 and 16. What we want is 14.5. 14.5. 14.5. And, well, basically, on this other side, we will have your U. Your U. Your U, what do you mean your U? Right? In this case, we want an H, right? Wait a second. So what are we going to put in here? What I recommend that you put in here, knowing that this is probably not something that you're not going to be sure of, is quality. Look at this, right? For 14 and for 14 bar, right? Your UF and your UG values correspond to 123.98 and 253.74. If we think about where 200 is in here, it's in the middle. Okay, so if your pressure were 14 bar, it would be saturated. In 16 bar, right, your UF and your UG values are 132.52 and 256, which means it's also saturated. So that means we are in saturated territory. Okay, it's very interesting. So now I recommend that instead of using U, I recommend that you should use quality. Quality in the sense that now we're looking at if you are, what do you call this? If you are saturated liquid, or if you are a saturated vapor. So in this case, basically values of F, right? 0 or F. And then we are looking here at values of 1 or G. What do you mean? Now, these are particularly difficult values because now, as you can see, each row, right? Each row of pressure corresponds to 2 grid rows in here. What I will be doing is that now I will be using their values of U and our values of H. Your U will be in white and your H will be in red. Okay, let's try this out. Right? Let's try this out. Your U value, or actually let's just try and put this all into one screenshot so I don't have to go back and forth. Okay. Let's put this here. Okay, so for 14 bar, your UF, right? Let's just put it here. Your UF values should be here, and your H values will be in here. Okay, so your UF for 14 bar will be 123.98. Your UF value for for 16 bar is 132.52. Okay, so for G, right, for your UG values at 14, that will be 253.74, and for this will be 256.00. Okay, essentially, now you know that your U value in this middle portion, I don't even know what quality this is, but for this middle value, you know that your U is at 200, right? Is at 200. And so what are we going to do? We need to find the corresponding H value in here, right? And now we look at the HF values. HF would be 125.26, and now in here will be 134.02. In this case, the HG, let's not mind this is HFG, right? This is 273.4, and then this is 275.33. Now we need to find this, which is basically how, right? How are we going to do this? Well, we're gonna have to do 1, 2, 3, 4, 5, right? 5 interpolations. Or, right, if you want 1, 2, 3, 4, 5 interpolations. But I don't recommend that because you don't even know the quality, right? So let's try it this way. Oops. This is 275.33. Okay, so let's try it this way. Let's try and find these values. And so if you're thinking about this, this is already like so much if you're just going to write things down in your normal mode. And by the way, if you want to return to the normal world, right, you just go in mode 1, right? Mode 1 is your normal solving mode, right? Mode 1 is for computation, right? Anyway, I should just keep that there. We will have 5 interpolations, right? So I will now put in here, right, numbers 1, 2, 3, 4, 4, and then 5, right? Excuse me. Okay, now let's try this out. We will have, right, our first interpolation, X, then Y, and then 1, and then 2. Let's put in here our lines. A line, then another line. Okay, and let's, 1, 2, 3. Oh, no, let's not put it here. 3, 4, and then last one, 5. Okay, this is like your ultimate test to know if you really do know your interpolation, right? Let's first start with the U values, right? Your U values are 14 and 16, right? And in this case, you want 123.98, and then you want 132.52. And so if you put in all of your values, you would ask for 14.5 y hat, right? So let me do that on my own. 14, 16, 123.98, 132.52, and then 14.5 y hat gives me 126.155. And again, if you don't want to do this thing, you can just have this and put this into A. Okay, A. Next, right, we go with our H values instead. So 14, 16, you will now go through 125. Let me put it in red. 125.26, and then 134.02. And again, you will ask for 14.5 y hat. And honestly, you know what? Let's just copy paste this as well. Copy, paste, paste, then paste here. Okay. And in here, you will have 14, 16, 125.26, 134.02. And then you will ask for 14.5 y hat. That gives you 127.45. Let's try and store that to letter B. Right, letter B. So there you go, letter B. And if you notice, everything in here for the first four will just consist of 14 and 16. Right? So if you want to just keep on using the same 14 and 16, there is a way to do this, right? So say for example, for your Casio, which I'm currently using, right? What you will do is you go back to the shift, right? Shift and then 1, that is for stat, right? And then shift 1, and then you will look at number 1, which is type, right? Type. Type in here does not mean like you type in the values. You want to change the type of the statistics that you are using. Or honestly, number 2 will take you back to the data. Ayun pala, number 2. Ayan. Number 2 will take you back to the data. So you can just retype instead of typing out the full 14 and 16 again, right? And for your canon, right? For your canon, it's the same thing, right? It's the same thing, apps, and then 2, right? So apps, you press apps, and then 2 for data. Okay? And so we look at our third bit. Number 2, number 3, number 4, and number 5. Okay, so for number 3, we will have this, right? Our U values 253.74 and 256.00. So shift 1, 2, we will have 253.74 and then 256. So again, we will ask for 14.5 y hat. We will get 254.305. Let's store that to letter C. So I'll do the same. 127.45. Let me store my values. 254.305, that is your C. And then let's shift 1, 2 again, right? And now we will have the fourth, right? The fourth interpolation. Let's shift that to letter C. Our fourth interpolation will have H values naman. 273.4 and then 275.33. So if we get these again, 273.4, 275.33, we will get 14.5 y hat, which is going to be 273.8825. So let's shift store that to D, 273.8825. So now we get D. And now here is the last bit, right? Here is the last bit. We will look at these two values and these two values, right? If you want these two things, right, you will have to first get the quality. I don't know what the quality of this thing is. Actually, this is the only time we'll see the quality, and you will even skip through that calculation, right? If you already have the value of A and C, you will be able to calculate the quality. But in this case, they're not asking for it. So why should I calculate for it? I'll just immediately go to the number 5, which in this case is now going to be this, right? If you look, your A value here corresponds to the fluid value, right? The saturated liquid value at 14.5. Your C, on the other hand, corresponds to the saturated vapor value for the 14.5 bar. And so now what we will do in here is we will look at A and then C, right? And because what we are looking for in here is the corresponding enthalpy at what do you call this? At an internal energy of 200, what we should look in here, what we should put in here is the values of B and D. Notice that if A is your internal energy, then B is your enthalpy. If C is your internal energy, then D is your enthalpy. If 200 is your internal energy, then your answer should be the enthalpy. So we will put these all together, shift 1, 2, and we will just put in all of our hard work, A, and then C, and then B, and then D. Okay? And then your stuff, or rather your screen should look something like this, right? 126.11, or let me just put these all back. And let me just copy paste this now, right? Your screen should look something like, let me just put this here. Your screen should look something like this. So it should look like 126.11, and then this is 254.3, this is 127.45, and this is 273.88. If you're wondering, ala, where are all of the exact values, right? It seems like they cut off this thing, but they're only cutting it off in the screen, right? If you hover over that value, you will still see the 25. Okay? And then now you're no longer asking for the value of 14.5 y hat. If you remember, all of your values in your x column are values of u, and all of your values in the y column are h. So that means we are now asking for what is the corresponding y hat for 200 kilojoules per kilogram, right? So 200 and then y hat, you will find that your h value, right? You will find that your h value is 211.8494. So 849 kilojoules per kilogram. So as you can see in here, the answer is actually 211.8494482. So as you can see, ridiculous amounts of accuracy, right? And basically this is your answer. So, right, these are 5 interpolations, right? And that's gonna be a lot if not for the kind of semi-automatic process that you have for this thing, right? The for mode 3.2, right? So thank you, mode 3.2. And yeah, there you go. That's it. We have 1 interpolation in here, we have 3 in here, and now you have 5 in here. Okay, so that's it, right? Thank you for listening, thank you for giving your full attention, and I hope you give this thing a try. Okay, thank you.